students, welcome to day 31 of 99% in 99 days for your 10th board series. Okay, so today we are going to do the third chapter of chemistry, that is metals and non-metals, where we are going to discuss the most expected questions. Okay, so this video is going to be very important. So if you are watching, so make sure that you attempt these questions, try them, note down these questions and practice them again. Okay, so let's get started here. I'll be telling you what you'll be getting in this particular video. So I've given you 5 MCQs, 4 short 2-marker questions, 5 3-marker questions, and we are going to discuss 9 5-marker questions and some case-based questions. Okay, so let's get started here. That is the first one. Which one of the following structures correctly depict the compound CaCl2? So if you see CaCl2, okay, it must be like this, right? Ca2 plus and Cl minus, right? Ca2 plus and Cl minus. So now that means what? Calcium has 2 plus charge. Then only if you do crisscross we will get this CaCl2. So here you see calcium has 2 plus, here also calcium 2 plus, here also 2 plus, here also 2 plus. So that is correct. Now chlorine has minus 1 charge. Okay, so here it is 2 minus, here it is 2, here it is 2, here it is 2, but here it is minus charge, right? So that is why this is the correct statement, or you can say the correct structure. So option number D is the correct answer here. Next, the compound obtained on reaction of iron with steam is, okay, so when you react with iron we get Fe3O4, so the correct answer is option number B. Next, an element X reacts with O2 to give a compound with a high melting point. This compound is also soluble in water. The element X is, okay, so high melting point means it should be generally a ionic compound. Okay, so you see high melting point means it should be ionic compound. Okay, next, ionic compound we have one metal and a non-metal, right? And it has already told that the non-metal is oxygen, so this has to be a metal. And if you see here we have iron as a metal, calcium as a metal, carbon is non-metal, silicon we can consider like it is a not very reactive because it is to the oxygen, it will not have high melting point. Okay, so out of iron and calcium we know that calcium oxides are soluble in water, so option number B is the correct answer. Next, the electron dot structure of chlorine molecule Cl2, that is Cl, right? So it is, if you see 1 2 3 4 5 6 7, 1 2 3 4 5 6 7, right? So this is, if this structure is there we'll get 8 electrons, octet is satisfied, so we will get okay, so this is there. So we will get a structure like this. Option number C is the correct answer. Next, question number 5, bronze is an alloy of. So if you see bronze, okay, so it is an alloy of copper and tin. Okay, copper and tin, option number D is the correct answer. Next, give reasons platinum. So we are now going towards the 2-marker question. Platinum, gold and silver used to make jewelry, and metals like sodium and potassium are stored under oil. So very easy question. So you know, because they are lustrous, they are ductile, malleable, and they are least reactive. Okay, so we can convert them to any shape, any design, because they are ductile and malleable. And lustrous, that is why they look beautiful, and you have, they are very less reactive, they won't get rust, nothing. So that is why we use these metals. Next, metals and sodium are stored under oil. So you know, sodium and potassium are highly reactive in the presence of air, right? So they immediately catch fire, and which can lead to a very big accident. So that is why, to prevent that, you keep sodium and potassium inside the oil. So what happens now? See, if you have sodium and you are having oil here, right? So now the sodium is not in direct contact of oxygen, right? It is not in contact of oxygen, so that is why it will not react and it can be stored safely. Next, question number 2, silver articles become black when kept in open for some time, whereas copper vessels lose their shiny brown surfaces and gain a green coat when kept in open. Name the substances present in air with which these metals react and write the name of the product formed. Okay, so name the substances present in air with which these metals react. So you know, copper and silver reacts with the sulfur present in the air to give you sulfides, right? which these metals react, and write the name of the product formed. So you can see silver articles when exposed to air turn black as it reacts with sulfur in the air to form a coating of silver sulfide. You can see this one. So the name of the compound is silver sulfide. Similarly, copper vessels lose their shiny surface as copper reacts with moist carbon dioxide in the air and forms a green layer of copper carbonate and copper hydroxide. Okay, this is the reaction. So that is what you should remember. For silver it is sulfur, and for carbon, for copper it is carbon. Okay, CC you can remember. Copper reacts with carbon dioxide to get to get corroded. Okay. Next, give reason carbonates and sulfide ores are usually converted into oxides during the process of extraction. Aluminium is a high reactive metal, still it is widely used in making cooking utensils. So here you can see, because it is easier to obtain a metal from its oxides than from its carbonate or sulfide ores. So that is why all the ores, carbonates and sulfides are first converted to their oxide form. Next, about aluminium forms a thicker protective oxide layer anodizing. So aluminium, when it gets oxidized, when it gets corroded, it forms an aluminium oxide layer. Okay, and that is why it cannot, that is why it protects the aluminium and it can be used as a cooking utensil. Next, name the metal of medium reactivity and write the 3 main steps in the extraction of this metal from its sulfide ore. Okay, so always remember, if it is sulfide ore, okay, first it should be converted to oxide. Okay, then it should be reduced to get the metal, and then it should be purified. Okay, clear? So sulfide to oxide to metal. So sulfide to oxide, what will happen? First it is roasting. Okay, oxide to metal, that is reduction. Okay, so you can see here, a copper is a metal of medium reactivity. 3 main steps of extraction of copper from its sulfide ores are roasting of copper sulfide, then you have reduction of copper oxide with copper sulfide, and then you have electrolytic refining. Okay. Next, question number 3 marks will go, what are amphoteric oxides? Give an example. Write the balanced chemical equation to justify your answer. So amphoteric oxides means those oxides which can react both with acid and a base. Okay. So for example, metal oxides showing both acidic and basic nature are called as amphoteric oxides. Now you have to write a balanced example, Al2O3 and zinc oxide. For reactions, you can see aluminium is reacting with acid here, right? So it is behaving, if it is reacting with an acid, it is showing the basic nature, right? And here it is reacting with an base, so it is showing acidic nature. Okay, so it will react and you will get salt and water, here also salt and water. Okay. Next, we will go to question number 2. During the reaction of some metals with dilute HCl, the following observations were made by a change. Silver does not show any change in this. Some bubbles of gas are seen when lead is reacted with acid. The reaction of sodium is found to be highly explosive. The temperature of the reaction mixture rises when aluminium is added to the acid. Explain these observations giving appropriate reason. So here you can see that since silver is less reactive, it does not react with dilute HCl. We know silver, gold, platinum, these are very less reactive metals, right? So they do not show any color, they do not show any changes. Next, when you react lead with dilute HCl, it will produce H2 gases, okay, which can be seen in the form of bubbles. So bubbles are seen due to the evolution of hydrogen gas. So Pb plus HCl gives PbCl2 plus H2. Next, we have the reaction of sodium is found to be highly explosive. Okay, sodium are highly explosive reactions. The reason for that is, as sodium is highly reactive metal, it reacts with dilute HCl vigorously, okay, and it produces a lot amount of heat. And next, the temperature of the reaction mixture rises when aluminium is added to the acid. The same thing, aluminium reaction, the reaction between aluminium and dilute HCl is exothermic, means heat is produced out, right? So the heat, due to the heat produced, the temperature of the container increases or it becomes warmer, okay? Yes. Next, given below are the steps of the extraction of copper from its ore. Write the chemical reaction. First, roasting of copper sulfide. So roasting takes place in presence of oxygen. So you have copper sulfide plus oxygen gives you copper oxide plus sulfur dioxide. Next, reduction of copper oxide from copper sulfide. So this copper oxide reacts with copper sulfide to give you copper and SO2. Next is electrolytic refining of copper. So when you do copper electrolytic refining, copper to it gives Cu2 plus 2 electrons at the cathode, okay, and you have yeah, so this is at anode, this is at anode, okay, and this is at cathode, okay. So 1 second, okay, yeah, clear. Next question. Explain the following. Sodium chloride is an ionic compound which does not conduct electricity in solid state, whereas it does conduct electricity in the molten state as well as in its aqueous solution. So here, if you know that ionic compounds in the solid state do not have free ions, right? So they cannot conduct electricity in the solid state. But when you dissolve any ionic solid in a solution, it starts to form ions, and because of these ions we can conduct electricity, right? So that is what in molten state, due to the heat, the electrostatic force of attraction between the oppositely charged ions are overcome. 1 second. Okay, one small error I have made here. This answer I will tell you. Okay, this is not the correct answer here. Okay, fine. Yeah, fine. You can see here. So in the molten state, due to the heat, the electrostatic forces of attraction between the oppositely charged ions are overcome. So the ions move freely and conduct electricity. In aqueous solutions, the ions are free, and that is why they can conduct electricity. Okay. So sodium chloride is an ionic compound which does not conduct electricity in the solid state, whereas it conducts electricity in the molten state as well as in its aqueous solution state. Okay, so molten state, how will it come? When you heat it, right? So when you heat the NaCl, the ions separate, the free ions are produced, and they can conduct electricity. And in the aqueous solution also we get ions, so that is why they can conduct electricity. Next, reactivity of aluminium decreases if it is dipped in nitric acid. So this is very important question. So due to the formation of a coating of aluminium oxide. So nitric acid is a very strong oxidizing agent. It oxidizes the aluminium and a thin layer of aluminium oxide is formed. Okay, so that is why the reactivity of aluminium is decreases, because now it is not directly exposed, it is covered by aluminium oxide layer. Next, metals like calcium and magnesium are never found in their free state in nature. Okay, so these are highly reactive metals, right? They react with all the elements present in the atmosphere, so we can never find calcium and magnesium as it is in the atmosphere. We can find calcium oxide, magnesium oxide, because these are highly reactive metals. Okay, so reactive metals like calcium and magnesium it reacts easily with different elements and occur in the form of ores. Next, we have a reddish brown metal used in the electrical wires when powdered and heated strongly turns black. Okay, when hydrogen gas is passed over this black substance, it regains its original color. Based on this information, answer the following question. Name the metal and the black color substance formed. So it is used in wiring. You can understand reddish brown, so it is definitely copper. And when it reacts with wait 1 second, when it reacts with which reaction when hydrogen gas is passed over this, it regains the original color. Okay, and black substance formed. So the black substance is turns black, and that is your copper oxide, right? So the brown color metal is copper, and the black colored substance is called copper oxide. Write the balanced chemical equation for the two reactions involved in the above reaction. So first reaction is copper plus oxide gives you copper oxide, copper plus oxygen gives you copper oxide. Now when you pass dry HCl gas, okay, over the substance, then copper oxide gets reduced. The hydrogen that is present, it reduces, and we get copper and water back. So that is why we get back the shiny appearance. Okay. Next, list in tabular form the difference between a metal and a not metal. So there are many points you can write down. So metals form basic oxides, non-metals form acidic oxides. Metals react with dilute acids to liberate hydrogen. Non-metals do not displace hydrogen and do not produce hydrogen gas. Metals are positively charged, non-metals are negatively charged. There are many other points you can write down, like they are sonorous, non-sonorous, conductors, non-conductors, with exceptions you need to write down. Okay. Next, give reasons for the following. Most metals conduct electricity well. So that is because metals have loosely bound electrons which can move freely and can conduct electricity. Okay. Next, you have the reaction of the iron oxide with heated aluminium is used to join cracked machine parts. So if you see here, in the thermite process, iron oxide is heated with aluminium, which results in the evolution of high amount of heat which melts the iron. The molten Fe is used to fill the cracked machine parts. So when you react Fe2O3 with aluminium, okay, we get Fe plus aluminium oxide plus heat. Okay, the heat that is produced here melts the metal. Okay, so that is why this can be used to join the tracks or to join the any broken parts. Okay, so because there will be liquid Fe in between that, and when it solidifies it will join both of them. Okay. Okay, next we have write the chemical equations for the following. Calcium metal reacts with water, cinnabar is heated in the presence of air, manganese dioxide is heated with aluminium powder. What are alloys? Least two properties of alloys. Okay, so first of all you have to write the reaction. Calcium reacts with water to give you calcium hydroxide and H2. HGS, that is cinnabar. Okay, you should be knowing the name of the ore, that is cinnabar is HGS, reacts with O2 to give you HgO plus SO2. Then we have MnO2 plus aluminium. Okay, so that is your Al2O3 plus Mn. Next we have what are alloys? Least two properties. So alloys are the homogeneous mixture of two or more metals of a metal and a non-metal. So properties means alloys are a mixture of more than one thing. It can be two metals or one metal and a non-metal. What are the properties? So alloys are stronger than the pure metals, then they are harder, have low melting point, more resistance to corrosion, and some are magnetic in nature. So any 2 points you can write down from here. Okay. Next, write the steps involved in the extraction of pure metals in the middle of the activity series from their carbonates. Okay, so if there is carbonate, you need to do calcination. If it is sulfide, you need to do roasting. Okay, how is copper extracted from its sulfide ores? Explain the various steps supported by the chemical equations. Draw the label diagram for the electrolytic refining of the copper. Okay, so first you can see that the metal oxides are obtained by calcination and converted into the free metal by using reducing agents like carbon, aluminium, which depend on the reactivity of the metal. So here first let me explain you. You have metal carbonates. Okay, metal carbonates by calcination give you metal oxides. Okay, and metal oxides will be then converted to metal by reduction. Clear? How is copper extracted from its sulfide ore? Explain the various steps supported by chemical equations. In the extraction of copper from its sulfide ore, when the ore is subjected to roasting, okay, so if you have in the extraction of copper from its sulfide ore, okay, if you have a sulfide ore, then what it is done? First it is done or heated in the presence of oxygen. Okay, so in the extraction of copper from its sulfide ore, when ore is subjected to roasting, some of it is oxidized to Cu2O, which reacts with the remaining copper sulfide to give the copper metal. In this process, copper 2+ behaves as the reducing agent. This is very important. So you have already seen this question. Copper sulfide is reacting with oxygen to give you copper oxide. Now this copper oxide again reacts with copper sulfide to give you copper. Now this copper should be purified by electrolytic refining. Okay. Next you have to draw the diagram. You can see this diagram. So there is copper ions here and it will undergo this reaction. Okay, with diagram you need to show it. Next we have metal M is stored under kerosene. It vigorously catches fire if a small piece of this is kept open in air. Dissolution of this metal in water releases great amount of heat and the metal catches fire. So the solution so formed turns red litmus blue. So you have to answer. So you have already guessed name the metal should be sodium, right? Next, write the formula of the compound formed when this is exposed to air. So sodium oxide will be formed, that is Na2O. Next, why is metal M stored under kerosene? You have already seen metals like sodium and potassium reacts with oxygen so fast that they can catch fire. Okay, so that is why they are stored under the kerosene to avoid the contact with oxygen so that they do not catch fire. Next is if oxide of this metal is treated with hydrochloric acid, what would be the products? So if oxide of this one is reacted with, sorry, one second. If oxide of this metal is stored with hydrochloric acid, then what will be the reaction? Okay, so sodium oxide reacts with hydrochloric acid to produce sodium chloride and water. So if I want to write this reaction, so Na2O plus HCl, okay, will give you NaCl plus H2O. Next, write the balance equation for the following reaction of M with air. So Na with oxygen will give you sodium oxide, the first one. Reaction of M with water. So sodium plus water gives sodium hydroxide plus H2 plus heat energy. Next we have reaction of metal oxide with hydrochloric acid. So Na2O plus HCl gives NaCl plus H2O. Okay, yeah, so these are the reactions. Next, what is a thermite process? Where is this process used? Write the balanced chemical equation for the reaction involved. So thermite reaction is in which iron oxide reacts with aluminium to produce molten iron. It is an exothermic process. Where is this process used? The thermite reaction is used to join the railway tracks. Okay. Next, write the balanced equation. So Fe2O3 plus 2Al gives 2Fe plus Al2O3 plus heat. Next, where does the metal aluminium used in this process occurs? In the reactivity series. So it is more reactive than iron, so it is placed above iron. Name the substance that is getting oxidized and reduced in the process. So if you see from Fe, we have removed oxygen, right? So Fe is undergoing reduction and aluminium oxygen is added, so aluminium is undergoing oxidation, right? So aluminium is getting oxidized to aluminium oxide and iron oxide is getting reduced to iron. By the common definition, you can easily tell this. Next, carbon cannot reduce the oxides of sodium, magnesium and aluminium to their respective metals. Why? And where are these metals placed in the reactivity series? How are these metals obtained from their ores? Take an example to explain the process of extraction along with the chemical equation. So carbon cannot reduce the oxides of sodium, magnesium because these metals have more affinity for oxygen. Okay, so that is the first thing, they have more affinity for oxygen than carbon. Next, where are these metals found in the reactivity series? They are found in the top of the reactivity series. Now, how are these metals obtained from their ores? So they are obtained by electrolytic reduction. So for example, extraction of sodium from molten NaCl by electrolysis. So what you do, molten NaCl is taken in an electrolytic cell and on passing electricity. So if you have Na plus, okay, and Cl minus, so this is a positively charged, so it will move towards cathode, right, where it will undergo reduction, and this one will move towards anode where it will undergo oxidation. Okay, so you can see at cathode what happens, Na plus electron give you Na, and here 2Cl minus loses 2 electron to give you Cl2 gas. Okay. Next, question number 7, write the balanced chemical equations to explain what happens when mercuric oxide is heated. So if you heat mercury oxide, we'll get Hg plus O2. Mixture of cuprous oxide and cuprous sulfide is heated. So that is the reduction of copper, right? So we'll get copper plus SO2. Now aluminium is reacted with manganese dioxide. So MnO2 plus Al, Al2O3 plus Mn plus heat. Ferric oxide is reduced with aluminium. So we'll get aluminium oxide, iron and heat. Zinc carbonate undergoes calcination. We will get zinc oxide plus CO2. Okay. So you have seen here, according to the mark scheme, you need to balance the reactions, otherwise half marks will be deducted. Okay. Next, by the transfer of electrons, illustrate the formation of the bond in magnesium chloride and identify the ions present in the compound. So you can see here, magnesium gives you Mg2 plus, chlorine forms Cl minus, then magnesium gives 2 electrons to both of the chlorine and a compound is formed like this. Ionic compounds are solids give reason, so due to the strong electrostatic force of attraction between the cation and the anion. Next, with the help of a level diagram, show the experiment setup of action of a steam on a metal. Okay, so this is the experimental setup. Here you can see you have the metal sample, okay, and then you are burning it. So from here glass wool soaked in water, so this glass wool soaked in water will produce steam, and this one will react here, and then we can find the hydrogen gas at the other side that is produced. Next, write the electron dot structure of calcium and oxygen. So the formation of calcium oxide by transfer of electrons. So this is electron dot structure of calcium. So 2 electrons, then 8 electrons, then 8 electrons, and then 2 electrons. Similarly, oxygen 2 electrons and 6 electrons. By the transfer of electrons, so 2 oxygen will be there, okay, sorry, oxygen gives 2 electrons to this, sorry, calcium donates 2 electrons to the oxygen, and we get Ca2 plus and O2 minus, and the formula of the compound formed is CaO, okay. Next, name the ions present in this compound. So it is calcium ion and oxide ion. List 4 important characteristics of this compound. So it is a solid, high melting point and boiling point, soluble in water, and conducts electricity in the molten state. So you can write any 4 properties of the ionic compounds. The answer will be same here, okay, fine. So students, here I want to tell you something about DSAT, okay. So now see, you are in 10th class, and after this you are going to choose a career, and in this you should take some guidance from the expertise people, right. So for that we have launched DSAT, that is Diksha Scholastic Aptitude Test. In this what you have to do is, you get a 60-minute lecture, then you write a test on that particular lecture, and a person evaluates that, tells you your strength and weakness. One-on-one mentorship counseling takes place, okay. So that is where you can know which is your strength and weakness, and you can choose the best career for yourself. So make sure, if you want to take the advantage of this thing, please go to the description section, register for DSAT, and take the full advantage of this and choose the best career for yourself, okay. Fine. So students, that's all in this class. So we are done with the metals and non-metals chapter. I hope you would have answered all the questions. If you have any doubt, please do not worry. You can comment down. I'll definitely address it, okay. Thank you for watching, and see you soon in the next class.